Welcome back! In the last video we talked about graphs. Now we're going to sketch them when given some information. So I just want to make sure you are aware of the fact that these are just sketches of graphs. Every one of you could have a different answer and have this be correct, because we're just sketching what the graph is supposed to look like and highlighting important points. Obviously, this is not x squared. X squared would not go through these 2 points. X squared would go through 0, 0, and then go up. So these are examples. These are just thoughts. But we're going to put it together. And the first one we're going to start with is when we have a positive x squared. So this is y is equal to something positive a value of x squared. And it could have some other junk afterwards, but remember, the most important part of the shape of this graph is the degree, whether it's positive or negative, and what some of your important points are. So this one, we know that our x-intercepts are -2, 0, and 4, 0. This is a positive x squared graph. So all we know is that this graph is going to look something like this. Now again, yours can look totally different from mine. You might have yours that's a little bit wider. Or maybe yours is much skinnier. The whole point of what I'm trying to tell you is it doesn't matter. We're just sketching based on some given information. So that's what I came up with. I plotted my x-intercepts. It's an x squared function. So we're just going to have a positive one, which means it opens up and goes into positive infinity for both of your end behaviors. And that is a perfect example for me. This next one, we have a -x cubed, and the factored form has been given. So we already know how to solve by factoring. We know that this would be -4, 0. This is a +1, 0, and this is a +6, 0. So we still know what all of our intercepts are. So we have a +6, 0, +1, 0, and a -4, 0. But now we need to take into consideration this x cubed is negative. If you go back to our video on polynomial graphs, an x cubed function looks something like that. But when you change it to a -x cubed, it starts high and finishes low. So this one, again, as far as where your turning points are, it really doesn't matter to me right now because we're just sketching. But you need to start up high, which means the first thing that's going to happen is you're going to go through here and come back low, but then you got to turn around, come back up, then you got to turn around again and go back down. Because remember, an odd function that's negative is going to have the pattern where it starts high and finishes low. Okay? So again, you had enough information. Yours might be a little bit different. Yours might go down lower and go up higher. But if it's a -x cubed, you must have started high and then finished low, turning twice to get through those points. Okay? One more example for you, because this is a pretty easy topic, is this last one. It's a positive x to the 4th. So we already know it's going to start high and finish high because positive evens open up. But we threw in some more information for you. We also threw back in a double root. So x-intercepts, we know we're going to have one of them at -4, 0. We have another one at 1, 0. And we have another one at 6, 0. But we threw in some other fun stuff for you. We have a local max somewhere on x equals 3. And we're going to have a local minimum somewhere on x equals -2. So we're going to put a maximum or a minimum down here. And then we're going to have a maximum. We're just going to say somewhere over there. Now we're just going to sketch our graph. Remember, this is a positive x to the fourth. And we need to pass through that point. So we're going to start up here and go down. And I said that you have to have a local minimum somewhere on that. So we're going to go back up, cross through. Here's another turning point for our max. And then remember, bounce. Remember what we mentioned about a double root. A double root means you bounce off the axis. So that's how it ended up being a W. Otherwise, you might have kept on going down here. But whenever you have a double root, this was a double root. That means you hit it from both the left and right, so it bounces off the graph. And that's why it still ends up being an x to the fourth power. Okay? So again, the purpose of this video, those graphs probably look nothing like they're really supposed to look like. Because an x to the fourth actually just looks like a parabola. It's all the fancy stuff that comes after it. But again, the purpose of this video is just to talk about different parts of a graph. Now you're just working backwards. Where we give you the info, you sketch it. Okay, this is Longo and I'm out. See you, bye.